Alright, you've seen inequalities now, and you're probably wondering, what are we going to do with these, right? How are we going to solve them? When would we ever use them? These are great questions. I'm glad you asked. We're going to start with Yvonne here. She's working as a tree planter for the summer. She's getting paid 10 cents a tree, which is a pretty decent rate, pretty typical these days. And she wants to make at least $200 a day. So that at least word right there tells us that she's not trying to make exactly $200, she's trying to make $200 or more per day. So our question is, how many trees does she need to plant each day? If we kind of look at this equation and try to start doing some translation, we can reason that at 10 cents per tree, we're going to multiply that by her number of trees, and that's going to equal her, we could say, pay per day, right? Why don't we just say right away with this, we want that to be greater than or equal to $200 per day. So the 10 cents per tree times her number of trees, she wants to be greater than or equal to $200 a day. We'll make this into an algebraic statement here. 10 cents, or 0.10 t, is greater than or equal to 200. And you can probably kind of reason to yourself that we're going to solve this thing just like we'd solve a linear equation. We'd divide by the 10 cents on both sides. So those cancel, we get t by itself, and t is greater than or equal to 2,000 trees. Notice we're not talking dollars anymore. Notice we divided dollars by dollars, so the signs actually cancel and we're left with trees. So she needs to plant at least 2,000 trees, right? So in that case, we solved in the same way, and now we should be asking, right, is that always how it's going to work? There is one exception, as the next statement says, and let me just kind of build us up to that. If we kind of recall back, when we had equations, we could do whatever we wanted to both sides of the equation, and it was still equal, right? We could multiply, we could divide, we could add, and the sides are still equal, right? Let's throw some negatives in here. Negative 2 is equal to negative 2, still equal. We could multiply perhaps by a negative here, and then we have it back to positive 2 is equal to positive 2. So that was when we were talking about linear equations. Everything was equal. So our change now, let's say we're talking about an inequality. 3 is greater than 2. Well, if we start playing around again, we can do a lot of the same things, right? 6 is greater than 4. Yeah, that's all good. We can divide by 2. 3 is greater than 2. That's all good. We can do some subtraction. Negative 2 is greater than negative 3. Still true. Here's where it changes. Take a look at this. If we multiply by a negative, now we get 2, 3. So in this case, this is no longer true. 2 is no longer greater than 3, right? We multiplied by a negative, and our sign doesn't work. We have to change our sign, right? We have to get rid of this. Whoops. And we actually need to flip that sign, right? Because now we have a 3 on the right, a 2 on the left. 3 is actually greater than 2, so this is the difference right here. Our one exception, and you can see that it would work the same way if we were to divide by negative 1. We would now get negative 2 and negative 3, and now we'd have to, whoops, excuse me guys, now we'd have to flip again, right? Now we would go the other way, we'd go back, now we're again saying that negative 2 is greater than negative 3. So the case here, the situations here where we can't just do the same to both sides is when we're multiplying or dividing by negatives. So to finish our sentence here, solving inequalities is the same as solving equations with one exception. That is when we multiply or divide by a negative, we flip the inequality. So greater than becomes less than, greater than or equal to becomes less than or equal to. Multiply or divide by a negative, we flip the inequality. Okay, that's the one change, and this is a significant change. It's tough to remember, but you gotta kind of remember why it happens, right? You gotta think back to this, that we can't just keep doing the same one thing to both sides. When we start throwing negatives in, it changes. The inequality has to change. We're going to solve a couple here, and then we'll make sure we know what to do here. So we're solving these guys just like equations, we're just watching for that multiplying or divided by a negative. Here we get x is greater than or equal to 10, and we can think about those values. We can think about kind of putting those values back into the equation and asking ourselves what would happen. So 10 minus 6 is 4, right? Is equal to 4. That works. If we had 11, 11 minus 6 is 5, so it's greater than 4, so it all checks out. Right? In this case, we're going to divide by a negative. So x, now we have to flip our sign. X is going to be greater than negative 4. And we've got to think it through again, right? So if we had a negative 4, so we're going to throw some values in here that are greater than negative 4. So we could throw in perhaps a negative 3. So negative 2 times negative 3 should be less than 8, and we get 6 is less than 8, so that works. We could throw in something else. We could throw in a negative 1. Negative 2 times negative 1 is less than 8. 2 is less than 8, so that works, right? So now we verify that our sign is going in the right direction, and we solved correctly for negative 4. Okay? Negative 5 is greater than x over 3. So here we're going to multiply both sides by 3. It's going to cancel that. And we get that negative 15 is greater than x. So solving those guys the same way, we're just watching for that multiplying or dividing by a negative here. That's our rule. Another case where we want to verify whether our solution is correct, so we're going to divide by a negative. Alright, so we're dividing by that negative 2. We've got to be thinking of what we're doing here. We're going to be left with x, and now it's going to be less than or equal to 11 over 2, and that's going to be negative because we had a positive, we divided by a negative. We could also write that as x is less than or equal to negative 5 and 1/2. And now we want to verify, right? So we want to substitute in some values. I'm going to do that over here, and I'll do that in blue. So let's verify with something that's less than or equal to negative 5 and 1/2. Let's just go with negative 6. So negative 2 times negative 6 should be greater than or equal to 11. 12 is greater than or equal to 11. So our verification checks out. It all works. We did our equation properly, and we remembered to flip our sign because we divided by that negative.